Database concepts and applications is based on Oracle Apex and the SQL sublanguage. For those of you new to this database environment, we'll explore many key concepts throughout this term to help you gain valuable hands-on experience and a greater overall level of comfort when working in Oracle databases. For those who may already have some Microsoft Access or other database experience, you'll find that Oracle is a much more robust environment. Oracle is specifically designed for multi-user applications. In fact, thousands of users can access the same data without any problems due to Oracle's transactional control features. As we get started with this week, we're going to explore a few of the following concepts. We'll define database terms. We're going to identify the purpose of database management systems, or the DBMS environment as you'll hear it called. We're going to explain the database design using entity relationship modeling and normalization. And we'll explain the purpose of a structured query language, which is also called SQL. As you'll find, there's a lot of terminology specific to the database environment. But the two core terms that you're going to see repeatedly is a database, which is a logical structure to store data, and the database management system, or DBMS. And this is generally software used to create and interact with the database. Now compared to Microsoft Access, which is almost exclusively designed for smaller databases, Oracle is largely considered to be a DBMS, or database management system software, that makes the many-to-many relationships among the different entities a reality in this database environment. We'll discuss the many-to-many relationships as we explore the entity relationship model later in this presentation. Now, let's begin to dive a little bit deeper into the terminology that really drives the database environment as we explore these key component terms in the slides ahead. The terms will be character, field, record, and file. Common with most other popular software, the character is just a basic unit which can be a letter, a number, or even a special symbol. A field is a group of related characters that represent an attribute or characteristic of an entity and corresponds to a column in the physical database. Moving forward, a record is a collection of fields for one specific entity for which corresponds to a row in the physical database. A file is a group of records of about the same type of entity. Now let's bring this all together. This slide demonstrates how each of these components fit together in the database environment. Notice in this example how the file groups all of the records and how each record groups each of the respective fields. Here, in this slide, we see an expanded version of how these components fit into the broader database view. You'll first notice that each of these data sets are tables. Tables are what we use in the database environment to collect raw data. In relation to the prior slide, you'll notice that a customer table might be used to collect a data field like first name, last name, city, state, etc. In a web form, for example, each of these fields would sync to a raw data table like the one seen here. This slide also highlights some key database terminology. As you will notice, the row or record refers to the horizontal alignment in the table, and a column is the vertical alignment. This terminology is especially important when we start creating our select statements. As we noted before, Oracle is considered by most to be a database management solution. In this slide, we explore the key features of a database management solution. Data storage is where we manage the physical structure of the database. Security is where we control the user access and privileges. The multi-user access is really where we're able to manage concurrent data access. The backup is really where we're able to enable the recovery options in the event of a database failure. The data access language provides a language that allows the database access. Data integrity is what enables the constraints or checks on the data within the environment. And a data dictionary is where we maintain the information about the overall database structure. I want you to think about database design within Oracle as really kind of combined, or as it's comprised of three core elements. And these core elements include the System Development Lifecycle, or the SDLC as you'll often see it, the Entity Relationship Model, or ER model, and the concept of normalization. Let's dig deeper into each of these. Here we get to dig deeper into the SDLC, or the Software Development Lifecycle, as it relates to the databases. It's important to also recognize that this acronym is also popularly used throughout many disciplines of software and systems development, and will not be exclusive to just the Oracle database environment. For this course, however, the Software Development Lifecycle, or Systems Development Lifecycle rather, will include the systems investigation, where we understand the problem, the systems analysis, where we're able to understand the solution, a systems design, where we're creating the logical and physical components of the database, the systems implementation, where we're placing the completed system into an actual operational environment, and the systems maintenance and review, where we're able to evaluate the system that we've implemented. So I want you to think of this as a circle or a cycle from the beginning, where we begin to automate, or initiate the systems, which would be the systems investigation, to where we're able to, come full circle to the systems maintenance and review. Next, let's talk a little bit more about the entity relationship model. The entity relationship model is a very important element of the Oracle environment, as it's used to depict the relationships that exist among entities in data. The following relationships can be included in an ER model. You'll find a one-to-one, a one-to-many, or a many-to-many. Simply put, an ER model is a diagram that identifies the entities, such as customers, books, orders, or otherwise, in a database, and it shows how the entities are related to one another. Whether one is developing software or a robust database, this is a helpful tool to help you define the logic of the physical systems that are to be built. Here is an excellent example of an ER model. What you'll see here is that each of the entities, maybe it's classrooms to divisions, share a relationship. The line is what represents this relationship. Here in classrooms to divisions, in the first example, you see the one-to-one. Next, you will find the example of a one-to-many, in which case there will be one instructor who may teach several classes. Likewise, as we move on to a many-to-many, you'll find that we have classes where there may be many and students where there may also be many. So here we have the entities that create a many-to-many relationship. Now, let's take a closer look at these. The one-to-one relationship establishes that each occurrence of data in one entity is represented by only one occurrence of data in the other entity. A great example would be the use of a social security number. This may also apply in an enterprise setting for a payment solution, such as a credit card. In the social security number example, each individual has just one social security number, and each social security number is assigned to just one person, creating really a perfect one-to-one relationship between the entities. In a one-to-many relationship, each occurrence of data in one entity can be represented by many occurrences of the data in another entity. The example, as we showed in the prior slides, is where a class may only have one instructor, but each instructor may have many classes. So what about a many-to-many relationship? Well, here, data can have multiple occurrences in both of the entities. A student, for example, can take many classes, and each class is comprised of many students. Let's take another look at the ER model. Here again is an example of what an ER model might look like. While we won't get to dive too deep into the development of ER diagrams, this brief example shows you how the different lines are used to depict unique relationships. Notice here that the branches that connect books with orders and author have multiple three-pronged connectors, which is to suggest a many-to-many relationship. Also, notice that the connection from publisher to books originates with one branch, suggesting a one-to-many relationship in this simple diagram here. Let's shift gear and begin a discussion about normalization. Database normalization is primarily used to reduce and/or control the data redundancy. Generally, this is a multi-step process that should have regular occurrence within the SDLC that we looked at earlier and should be carried on throughout the lifetime of database until the database is retired. So what is data redundancy? This refers to having the same data in different places within the databases. Likewise, data anomalies refer to inconsistencies within the data. So what is this concept of unnormalized data? If there's normalized data, there must be unnormalized data. Well, unnormalized data is becoming less popular within the database environment. But nonetheless, is still seen, especially in legacy systems. I'll admit, this isn't the best example in this presentation, so to better explain normalization, I'll encourage you to do some independent research. Let's begin to discuss normalization a little bit further. Here we're going to talk about the first normal form. We're entering the content area now of primary keys. The first step in determining which data should be stored in each table is identifying the primary key. The primary key is a field that uniquely identifies each record. The first normal form, or 1NF as you often see it, indicates all values contain no repeating values. First normal form can have a profound effect on data management, especially when financials are involved. As we continue the discussion on first normal form, I want you to start thinking about situations where you may have more than one field used as a primary key for a table. Here, this combination of fields is generally called the composite primary key. You will find that ISBN and author can combine, for example, to create a primary composite key. When more than one field is used as a primary key, like we said, this is generally called the composite primary key. Once you have resolved any of the partial dependencies in the database, at that point your data has actually moved into second normal form, or 2NF as you'll see it written. The next few slides will show graphics to depict this a little bit better. So, to take us here to the third normal form, what we have done is eliminated from all of the repeating groups to get us to a first normal form. Then we remove all of the partial dependencies, which would be done in the second normal form, which brings us to the third normal form, where we delete or remove any transitive dependencies in the data. In summary of the normalization, first normal form allows us to eliminate the repeating groups, identify the primary key, and in second normal form, the table begins in a first normal form, from which we then remove any partial dependencies. From that second normal form, then we're able to push further in removing the transitive dependencies, which would bring us to a third normal form. These generally comprise the primary steps that you're going to find in any normalization exercise. Within the database environment, this is often an exercise that can be guided by certain tools and optimization techniques within the database. It's nonetheless an important concept to understand as you build the foundations of your database knowledge.